CNC machining is a powerful and versatile fabrication technology that can be used to create models, components, 2D geometry, 3D geometry, signage, furniture, and a range of other manufactured products. In fact, CNC, or Computer Numerical Control, is a broad term that encompasses many computer-aided manufacturing processes. In DMaF, our main CNC technology is our CNC routers. These are industrial machines that mount cutting tools, also known as router bits, onto a rotating spindle motor to cut through a variety of materials. CNC is a subtractive process, so it starts with a block of material which is called the stock, and then a tool, rotating at high speed, progressively cuts away at that stock until the desired form is achieved. Typically, a CNC job will either be two-dimensional or three-dimensional. Two-dimensional CNCing is similar to laser cutting, where the outlines or profiles of a part are cut out from a single sheet of material, such as plywood. This is often used to create furniture, one-to-one prototypes, or architectural components. Three-dimensional CNC allows you to replicate a 3D model and sculpt complex forms. However, it's much more time-consuming and a little bit more complicated to program than the 2D toolpath. 3D CNCing is often used for object prototypes, molds, and topographies. The CNC machining process includes selecting your stock, preparing a 3D model, generating a toolpath, and cutting your object. Step 1 starts by selecting a stock material for your project. Your 3D models will be cut out of this material, so make sure it fits within this stock. Step 2, prepare a 3D model of your object. This model must be designed with consideration given to the limitations of the CNC manufacturing process. Step 3, the CNC machine requires a toolpath to follow in order to cut out your object. In DMaF, we use the Autodesk product Fusion 360 to generate these toolpaths. A CAM file specifies things like the type of tooling used and the speed at which to cut. These are important factors that must be correct in order to successfully cut out the material. Step 4. Once these items are in place and the file has been successfully programmed and simulated, the CNC can be run. After the machine has finished cutting out your design, you may wish to do some post-processing, such as sanding and painting. Like all manufacturing processes, it's important to know its limitations. Your design must consider these limitations or it won't be able to be manufactured. In this induction, we'll cover some general information that you'll have to know about CNC machining, design guidelines to get you started, and cover how to prepare your 3D model for CNC manufacture.